In a previous video, we looked at absolute value equations. In this video, we're going to look at absolute values involving inequalities. Remember, those are symbols like less than, greater than, less than or equal to, greater than or equal to. Remember also that we talked about how absolute value is the distance away from zero on a number line, and it's always positive. So here we are asked to find all the numbers x where their distance is less than 4 on the number line. So here's 4, here's 0, so less would be 3, 2, 1, and everything in between. So it would be all of those numbers would have a distance that's less than 4 on the number line. But what about negative 4? This distance is 1. This distance is 2, that distance is 3. So all of those also have a distance of less than 4 on the number line. Now we're not going to include the number 4 because that would have a distance equal to 4. Everything I've shaded in yellow has a distance of less than 4. So how can we write that answer? Well, x represents all of those numbers, and there's an infinite amount, not just 1, 2, 3, but 1.1, 1.2, all of those little numbers that we really literally cannot write out. How do we write that? Well, x is going to be less than 4, that's all of those numbers, but it's also, you kind of have to read it backwards, x is greater than negative 4. That's all of those numbers. Negative 3 is greater than negative 4. Anything to the right on a number line is greater than. So this is what we call a sandwich inequality. The easier way to write that answer is in interval notation. And remember, we used that when we were looking at the domain of a function earlier. So we could say from negative 4 to positive 4. And remember, we use the parentheses because of the open circles. Let's look at this next one. X is greater than or equal to 3. So we find 3 on the number line, equal to because of the equal to part of the inequality. And so we want numbers that have a distance that's bigger than 3. So like 4, 5, 6, and we would keep going out that way. So again, we have an infinite amount of those, so let's just shade. So everything to the right of 3 has a distance that's greater than 3 on a number line. But again, we also have to look at that negative value. Remember, that absolute value is equal to 3. So what would be bigger? Going out that way. We're going further and further and further away from 0 on a number line. So all of those numbers would have a distance bigger than 3. Now look at that picture. Look at these two pictures. One is shaded in between, and then the other is two separate ones. How do we write that? Well, this part says x is greater than or equal to 3. That's all of those numbers. This part says x is less than or equal to negative 3. That's all of those numbers. And mathematically, we really should put the word or. Again, we could write that in interval notation. So this part would be bracket, remember, because it's equal to 3, goes on forever. This part would be, we'd have a bracket at negative 3, and yes, I'm kind of writing it backwards, and we kind of start out to infinity, so from left to right. So, negative infinity all the way to negative 3. And we can replace that word or with a U that stands for the union. So we have negative infinity to negative 3, union 3 to infinity. The key part here is we have a sandwich here, in that x is in the middle, and over here we have an or statement because we can have one thing or the other. So let's break it down into a process. Again, you have to isolate that absolute value just like we did on the equation. And then we have to say, well, what is that symbol? Is the expression less than or is it greater than? If it's less than, we use that sandwich inequality. A fellow teacher teaches it like this, and I love it. A less than which. Maybe that will help you remember it. So we would put that expression in between the number positive and negative. Look at how we're going to write those symbols. If you read it from left to right, it would be less than. We're going to solve, we're going to graph it on a number line, and we're going to write our answer in interval notation. If it's greater, again, we have to isolate, look at that symbol, and we say, it's greater than. We have to write it as two separate inequalities. Much like we did the equations, we have to do greater than the number, less than the negative number. Again, one way you could remember this, and I stole it from a different teacher, is you want to look at greater. Now granted, that's not how you spell greater, but greater will help you remember that you need to have two separate expressions. So let's just look at our examples. I know this is kind of hard. So the first example, our absolute value is by itself. And so what we have to look at is that absolute value. Is that less than 8 or greater than 8? Well, that's a less than symbol. So we want a sandwich. So we're going to take out the absolute value bars. So write that expression. Write it just like it looks on your paper, the problem, except for the absolute value bars. But we have to sandwich it between not just positive 8, but negative 8 as well, and write that same symbol. Now we're going to solve for x. So we need to add 4 to all three parts. So we have negative 4 less than or equal to x less than or equal to 12. So x has all the values between negative 4 and 12. I want to graph that on a number line, nothing too fancy. We want to include those because of the equal to part, and we would shade between. And then the last thing I'm going to ask you to write your answer in interval notation. So we go from negative 4 to positive 12 in brackets. Let's look at the next example. Our absolute value is by itself, and this time of course we have a greater symbol. So we write it just like it is without the absolute value, and then you want to write it without the absolute value, flip that symbol and change the sign. Flip that symbol and change that sign. And so we have between 9, not between, but we have to regard it between 9 and that negative 9. Now let's solve for x. So subtracting 2, and so we have x is less than negative 11 or x is greater than positive 7. So we have negative 11, positive 7. So this part, open circle because it's not equal, greater than is to the right. This part, again, open circle because it's not equal to, but we have less than going further away. Remember, we're trying to be away from 0, bigger. So we have solved, we have graphed it. Now write the answer in interval notation. Remember our union symbol. There you have it. So yes, it takes some memorization, and yes, we're going to work a couple of more examples. All right, so on these two, you can hopefully see that the absolute value is not by itself. So we need to isolate that. So that means we need to get rid of that negative 2. Before you do anything for else, you have to isolate that absolute value, just like we did on the equations. Now, once it's isolated, you look at that symbol and you say, is that a greater than or a less than? If you have your absolute value on the left-hand side, it makes it really easy because we just want to read it left to right. So that's a greater, so we know we have an or, so we want to write it just like it is. But we also want to write it with the comparing it to the negative 11, so we want to flip it, change that sign. Flip it, change that sign. So here we're going to add 1 and divide by 3. Here we're going to add 1 and divide by 3 again. And again we have OR. So putting it on the number line, and again, number line doesn't have to be fancy, filled in. Less than is going that direction. Greater than is going to the right. Okay, so greater. So from negative infinity to negative 10/3 bracket, union bracket 4 to infinity. Next example. Ooh, we have to do a lot of work to isolate that. We've got a 2 and a plus 5. So again, just like the equation examples, we're going to subtract 5 first. Then we have to get rid of that 2, and it's being multiplied, so I want to divide by 2. Look at how I'm keeping that absolute value, all right? Until I isolate it, I have to keep it. Now I can see that this is a less than, so I want to do that sandwich. So you want to write it just like it is, but then sandwich it in between the negative 3. Sandwich it in between that negative 3 and positive 3. Now let's subtract 3 from all 3 parts. Notice we have x's between a sandwich. Here's negative 6, here's 0. They're open circles, shading in the middle. And then writing it in interval notation. So isolate, then decide, sandwich or greater. Now these two examples are going to really test your brain about the definition of absolute value. Remember, it's distance, which is always positive. So we're going to isolate that absolute value, so we're going to subtract 7 from both sides. And yes, this is a less than. We could sandwiches, but stop. That's a negative number. Look at what this is saying. Absolute value, which is distance, which is positive. They're saying less than something negative, a negative 1. When you have a negative on that symbol, you want to stop and ask yourself, hey, what's going on? All right, so we have something positive, less than negative. Is that possible? Are positive numbers ever less than negative? No. So this is not possible. So that means we have no solution. It's the negative that brings up those red lights and say, wait a minute, I need to think about this. All right, let's look at the next example. Again, I need to isolate that absolute value. So I need to subtract 5 again. And my warnings go up, but you can't just say, oh, it's no solution because it's negative. Look at that symbol. This is greater than. So this is something positive. Remember, absolute value is always something positive. Greater than negative 4. Isn't something positive always bigger than something negative? This is always true. Something positive is always bigger than something negative. So this answer, you could write it as all reals or an interval notation from negative infinity to positive infinity. These two going to take you a little bit of work of memorization. In fact, all of it is. You really need to know this process. Trying to give you some cute things to help you remember how to set these up.